Hi, my name is Barrett Givens from Cal Poly Pomona, and I want to talk to you today about multi-digit multiplication. So I want to look at an example. Let's consider the example 23 times 41. I've been seeing, it's been coming up on my Facebook and other places on the internet, I've been seeing some people posting a video showing how to do it using lines, sort of like this, using 2 lines and 3 lines for 23 and making a diagram. And I also assume most people in the US at least are familiar with the standard algorithm that looks kind of like this. And I also know of a number of people who've told me that they are familiar with the lattice method where you make sort of a grid and put the numbers 23 and 41 on the side like this. So what's the best way? What's the right way? Or how should we be teaching our children? To start off, I first want to show you how to do 23 times 41 and what I sort of consider the formal mathematician's way. Now, this would not be the way that most people would ever do it in real life, but so that we can kind of see what's going on, let's go ahead and do it this way using algebra. So what I'm going to do is I'm going to expand the numbers. 23 is really, the expansion of that is 20 plus 3. And 41, the expansion is 40 plus 1. And when I multiply two sums like this, I can do that using FOIL. FOIL, which you probably remember from high school algebra. So first we multiply the first terms, 20 times 40. Outer terms, 20 times 1. Inner terms, 3 times 40. And finally the last terms, 3 times 1. And I can multiply, I can do all of those products in my head. So 800, 20, 120, and 3. I'll group together the two middle terms. Now that middle term 140, that one I want to separate that into its hundreds part and its tens part. So I'll write that as 100 plus 40 in the middle. And now I can put the two terms that are hundreds together, the 800 and the 100, to give me 900 plus 40 plus 3. And that's just the decimal expansion of the number 943, and so that's my answer. Okay, and that thing where I changed the 140 to 100 plus 40, and then I put the 100 with the 800, probably some of you have heard that referred to as regrouping. Okay? Now let's do the problem again, but using the standard algorithm that most people in the United States learn as children. So for that algorithm, we write the two numbers, 23 times 41, above each other with a line. And I'm going to start by multiplying the 1 times the numbers on the top row. 1 times 3 is 3, 1 times 2 is 2. Next, I do the 4 times the numbers on the top row. 4 times 3 is 12. I don't write down a 12 because it's a two-digit answer. I only write down the 2 below and I put a 1 up above. That's like so-called carrying the 1. Then I do 4 times 2. 4 times 2 is 8, but because I carried that 1, I have to add that on there and I get 9. Then I add and I get 943. Okay. Another method some people have seen is the so-called lattice method. So you make a grid, since these are two-digit numbers, it's a 2 by 2 grid, and I'll put 23 on the top, 41 on the side, and then I put diagonal lines like so. Now, in each square, I multiply the number above and the number to the right to find out what goes in that square. If it's just a single digit, I put it on the bottom side of the square. So 4 times 2, 8. The next one is 3 times 4, that's 12. That's where I use the upper part of the grid. So I write 12, I put the 1 above and the 2 below the diagonal line. There's my 12. Now on the bottom, the lower left, I have 2 times 1, and then the lower right, 3 times 1 is 3. Now you add along the diagonals 3, 4, and 9, and that gives me the answer 943. Okay? Now let's do the method that I've been seeing on the internet with the little lines. So you make lines to represent 23, 2 lines and 3 lines. Similarly, to make 41, I'll make 4 lines and 1 line. And then I'm going to count the number of dots, I'm going to count the number of crossings in each little area. Starting on the far left, I have 8 crossings. Going up above, I have 2. Down below, I have 12. And then over on the far right, I have 3. Now I add these numbers vertically. 3, Those two together make 14, and then on the end I have 8. Now that 14, because it's a 2-digit number, I have to change it to a 4 and carry the 1 over to the next level, and so that 8 becomes a 9, and altogether I get 943. Okay, so happily we got the same answer all 3 times. I'm going to do one more thing. One way that I think is very natural to think about multiplication is to think of the product of two numbers as being the area of a rectangle whose sides are those two numbers. So here's a rectangle. I'm going to try to make a rectangle that is 41 by 23. So across the top, 10, 20, 30, 40, and 1. And down the side, 23. So the product, 23 times 41, will be the area of this rectangle. So I can just find the areas of all the little pieces inside that rectangle and add them together. Each 10 by 10 square has area 100 square units, so those are all 100. Together there's 8 of those, so that's 800. Now on the bottom I've got 3 times 10 for each of those rectangles, so each of those is 30. And when I add those up I get 120. On the far right, those long skinny rectangles, those are each 10. And then in the bottom I've got 3. And then I add those all together. I've got 800, so that's 800, plus another 120 makes 920. Then down the right hand side, 920, 930, 940, 943. And so I get 943. Alright, well, I got the same answer with all 5 methods, so I'm feeling pretty good right now. I'm feeling pretty confident in my answers. And I contend that we're really doing the exact same thing in all of these methods. I mean, in all cases, we're really just multiplying 23 times 41, and so it's the same thing, it's just different ways of writing it and keeping track of what's going on. In all cases, we end up doing 4 multiplications of 1-digit numbers. We do 2 times 4, 2 times 1, 3 times 4, and 3 times 1. In all of the different methods, we end up doing those 4 multiplications, corresponding with the 4 colors, red, purple, green, and blue, that I've I hope, color-coded them. And then the different shortcuts, really what they're doing is they're helping to keep track of what goes in the ones place, what goes in the tens place, what goes in the hundreds place. In the long method here, that I'm doing here, in this method, I don't have to keep track because I'm actually just writing. I'm not writing 8 for short, I'm writing 800. So I'm keeping track just by writing it down fully what the number stands for. In all the other methods, I have a method or a way of keeping track of what's going on. So in the standard method, what do I have? It goes by columns. The first column is the ones, the second is the tens, and the third is the hundreds. In the lattice diagram, in the middle, it goes by the diagonal lines. The lowest diagonal is the ones, then the middle one, that represents tens, and then the next one is hundreds. In the crisscrossing lines method, the ones, tens, and hundreds are coded by the vertical groupings. So the first one there is ones, these are tens, and these are hundreds. Okay, and so, for example, let's look at all of the numbers that are blue. If I look at all the blue numbers, what I can see is that in each case I did a 3 times 1 to get the 3. And over here, the 3 times 1, the 3 is in the ones place, so that stands for 3. Over here, the 3 is in the ones diagonal, so that stands for 3. Over here, the 3 is in the ones area, and so that stands for 3. And then over here, it really was just 3 times 1, which is 3. Okay, so all of the 3's, they all came about by doing 3 times 1, and then remembering that the 3 that we got was in the ones place. Now let's look at the purple ones. So the purple ones, I've highlighted all of them now. Over here, the purple one, it came from doing 2 times 1, and I placed it in the tens column, so that means it stands for a 20. Here it just is a 20. Here it's a 2, but it's in the tens diagonal, so that's a 20. Over here it's a 2, but it's in the tens area, so that's a 20. And then over here you can see, yes, it's a 20. So in all cases I'm getting the 20 is that purple number. Okay, now let's look at the greens. So the greens, I've got over here, the green came from doing 3 times 40, which is 120. On this grid diagram, I have the 1 in the hundreds place and the 2 in the tens place, so that's 100 plus 20, which is 120. Over here, I have a 12 in the tens area, so 12 tens, that's 120. Over here, I have 30 plus 30 plus 30 plus 30, that's 120. Over here, I have the 2 in the tens place, so that makes 20. And now I've carried that 1. It's actually a little strange. The way I've carried it, it doesn't look like it's in the hundreds place. So that's one thing I think that makes the standard method a little confusing. That 1 up there really represents 100, which is why it got added into the number in the hundreds column. But at any rate, that is also a 120 there. Okay, and then finally, real quick, let's look at all of the 8s, the red numbers. So remember from the beginning that 8 stood for 800. Over here, well, I don't have an 8, I have a 9. Remember where that came from. I say that the 8's kind of hiding in there. That 9 came from doing 4 times 2, which is 8, but the extra 1 from the 120 got added in there. So there's the 8's sort of inside there. Here's an 8 in the hundreds diagonal, which stands for 800. Here's an 8 in the hundreds area, which stands for 800. And up here, here are 800s. And so in all cases, we're getting an 8, which stands for 800, which always has come from doing 2 times 4. So I'm just doing the same things over and over again. In all cases, I'm doing 2 times 4, 2 times 1, 3 times 4, 3 times 1, and then the different algorithms just help me keep track of the place value. Is this number a 1, a 10, or a 100? And then I can combine numbers. If 2 numbers are both 10s, then they can be combined to give me the 4 10s in my answer. Alright, so hopefully, what I'm hoping that you see out of all of this is that really it's just the same thing. All of the methods are really just the same process over and over and over again. And so which one's the right one to teach the kids? Well, it doesn't actually matter. I think if the kids understand what they're doing, then any of the methods is good. If they don't understand what they're doing and they're just memorizing a method, well, then that's prone to error and is a lot harder for a kid to understand. Like, well, why do we put these numbers here? I think the area method is really great when somebody's just starting out because it's concrete and you can see why, you actually physically see all those numbers adding up together. I think that the crisscross line method is really cute and is good for small numbers and especially numbers with small digits. I wouldn't want to do it with like 997 times 858. It would be pretty gross. It also has some issues if you have zeros, if you have a multi-digit number with zeros in it, whereas the standard method is really good at handling when you have zeros in it. And then, the lattice method in the middle, to me, it's kind of like almost a cross between the standard method and the crisscross line method. But ultimately, what I would say is as many methods as people learn, the better, and especially if you understand the connections between the methods and understand that they're really just all equivalent to each other. My having done this with 5 different methods and getting 943, like I said, I am so confident now that I got the right answer, whereas if I'd only used one method, I would be pretty prone to careless errors and typos. So I definitely understand now why 23 times 41 is equal to 943.